Good day everyone. For today's video, we will be discussing arithmetic and geometric sequences. So here are the following agendas. We will learn how to find an nth term of an arithmetic and geometric sequence, solve to find arithmetic and geometric means and series, and we will learn how to determine convergent and divergent infinite geometric series. Now, let's proceed with our discussion. As shown in the previous slide, we will first tackle arithmetic sequences. So, arithmetic sequence is also known as arithmetic progression. It is a sequence of numbers such that the difference from any succeeding term to its preceding term remains constant. This constant term is a common difference. The sequence 6, 9, 12, and 15 is an example of an arithmetic sequence with a common difference of 3. This is because when any term subtracted from the following term is equal to the common difference. For example, 6 subtracted from 9 is equal to 3, as well as 9 subtracted to 12. Now, let's try to solve. Example: given the arithmetic sequence 12, 16, 20, 24, and 28, and the common difference of 4, find the seventh term of the sequence. To find the seventh term of the given sequence is to use the general term of the sequence. The formula is a sub n is equal to a sub 1 plus n minus 1 multiplied to d, the common difference, where a sub 1 or the first term is 12, and the n or the number of terms is 7, and d or the common difference is 4. Then, substitute the values into the general term formula. A sub 7 is equal to 12 plus 7 minus 1 multiplied to 4. So, a sub 7 is equal to 12, 7 minus 1 is 6, that's why 12 plus 6 multiplied to 4. A sub 7 is equal to 12 plus 24 because 6 times 4 is 24. Therefore, a sub 7 is equal to 36. Here are the steps we followed. First is we determined the values. Next, we substituted the values into the formula, and finally, we simplified it to find the seventh term. Now, arithmetic means are the terms between any two consecutive terms of an arithmetic sequence. For example, the two arithmetic means in the arithmetic sequence 1, 4, 7, and 10 is 4 and 7. Now, let's try to find the four arithmetic means of the arithmetic sequence whose first term is 6 and last term is 36. To find the four means of the given sequence is to use the formula a sub n is equal to a sub 1 plus n minus 1 multiplied to d, because we are looking for the common difference of this sequence. Now, we have to substitute the values. A sub n is equal to 36, a sub 1 is equal to 6, and n is equal to 6. Then, 36 is equal to 6 plus 6 minus 1 multiplied to d. Then, 36 is equal to 6 plus 5 multiplied to d. 5 because 6 minus 1 is 5. And then, 36 is equal to 6 plus 5d because 5 multiplied to d is 5d. Then we have to transpose 6 to the other side. It becomes 36 minus 6 equals 5d. If we get the difference of 36 and 6, we simply divide 5 both sides to get d, which is we get 6. Therefore, 6 is the common difference of this given sequence. Now, let's make sure we completed these steps. Yes, we indeed determined and substituted the values into the formula, as well as simplified in order to solve the common difference. We also added the terms to the common difference in order to find the four arithmetic means. Now, let us proceed to the arithmetic series. Arithmetic series is the sum of all the terms in an arithmetic sequence. Let's try to solve this exercise. To find for the sum of an arithmetic sequence, we will use the formula s sub n is equal to n over 2 multiplied to a sub 1 plus a sub n. Now, to solve this problem, we are already given the corresponding values to the variables. Therefore, we just need to substitute the values into the formula. And there we got 22 as the final answer. Next is the geometric sequence, also known as geometric progression. It is a sequence of non-zero numbers where each term after the first is found by multiplying the previous one by a fixed, non-zero number called the common ratio. Now, let's try to solve a geometric sequence. Given the example -2, 6, and -18, we have to find the common ratio and its eighth term. To find the common ratio in the geometric sequence, we just simply divide each number from its preceding term in the sequence. For example, a sub 2 or second term divided by a sub 1 or the first term is equal to r or the common ratio. In our sequence, 6 is the second term and -2 is the first term. That is why 6 is divided by -2 is equal to -3, which means the common ratio of this sequence is -3. Now, let's find the nth term of the geometric sequence given through the formula of a sub n is equal to a sub 1 r is raised to the power of n minus 1. Now, let's substitute the given values. A sub 8 is equal to -2 multiplied to -3 to the power of 8 minus 1. A sub 8 is equal to -2 multiplied to -3 to the power of 7 because 7 is the difference of 8 minus 1. A sub 8 is equal to -2 multiplied to -2187 because it is the answer of -3 raised to the power of 7. Then, a sub 8 is equal to 4374. Therefore, the eighth term of the geometric sequence given is 4374. So, here are the steps we followed. We looked for the common ratio by dividing each term from its preceding term. And again, we determined and substituted the values as well as simplified in order to get the eighth term. Geometric sequence also has geometric means and geometric series, just like in arithmetic means and arithmetic series. Geometric means are the terms between any two consecutive terms of a geometric sequence. In geometric means, there are three geometric means in the geometric sequence 2, 4, 8, 16, and 32. And the geometric means of this given sequence is 4, 8, and 16. Let's try to find three geometric means of the sequence whose first term is 2 and last term is 32. To find the geometric means of a given sequence is to use the formula a sub n is equal to a sub 1 r raised to the power of n minus 1 to find the common ratio of the sequence. Let us first identify the corresponding values to the variables in the formula, where a sub n is equal to 32, a sub 1 is equal to 2, and n is equal to 5. If you are wondering why n is equal to 5, it is because two terms are already given and we have to find the three terms in between these two terms. Next, let's substitute the values into the formula so that we can simplify and find the common ratio. Now, after getting the common ratio, which is 2, we'll first multiply the first term by 2 and so on until we get the last term, which is 32. Therefore, 4, 8, and 16 are the three means. Now let us move on to the geometric series. Just like an arithmetic series, geometric series is also the sum of the terms in a geometric sequence. As we dig deeper into this topic, let's try to solve this exercise. The formula used to find the sum of a geometric sequence is S sub n is equal to a sub 1, 1 minus r raised to the power of n minus 1 divided by 1 minus r. To find the common ratio, we simply divided -10 by 2. Now, given the geometric series, we first need to identify the corresponding values where a sub 1 is 2, r is equal to -5, and n is equal to 9. Next, we substitute the values into the formula, which makes it s sub 9 is equal to 2, 1 minus -5 raised to the power of 9 divided by 1 minus -5. And then, we simplify. Thus, the sum is 651,042. There are two types of geometric series, the convergent series and divergent series. Convergent series are infinite geometric series opposite to divergent series, whose common ratio is less than 1 and its partial sums tend to a specific number called a limit. If an infinite geometric series is convergent, its sum can be calculated by using the formula S is equal to a sub 1 divided by 1 minus r. And divergent series is an infinite geometric series wherein the common ratio used in the sequence is more than 1. You cannot find its overall sum because it does not have a finite limit. Here are some examples of convergent and divergent series. The sum of the geometric series 4 plus -8 plus 16 plus -32 can be found because its common ratio is -2, which is less than 1. Therefore, the geometric series is convergent. Another example is the sum of the geometric series 6 plus 24 plus 96 plus 384 cannot be found because its common ratio is 4, which is greater than 1. Thus, the geometric series is divergent. Now, let us try to solve this exercise. The formula used to solve the sum of the convergent infinite geometric series is s sub n is equal to a sub 1 divided by 1 minus r. To prove that the given series is convergent, we have to find its common ratio by dividing any term from its preceding term. Therefore, 3/4 is the common ratio because 3/2 divided by 2 is equal to 3/4, and it is less than 1. Now let's identify the values. A sub 1 is equal to 2, and r is equal to 3/4. Then we substitute these values into the formula, which makes it s is equal to 2 divided by 1 minus 3/4. And then we simplify. Now let's proceed to this next exercise. Again, in order to determine if an infinite geometric series is convergent or divergent, we need to first find its common ratio. By dividing 14 by 7, we get 2, which is the common ratio of the given series, and it is greater than 1. Thus, the given infinite geometric series is divergent. If you want to improve, you can practice with these problems. So here ends our discussion. Thank you for listening and watching our video. We hope that you will learn about arithmetic and geometric sequence. Thank you.